Hello everyone, welcome to the channel and welcome to another video. So today we are going to talk about one of the most important topic of IGCSE, which is redox reaction. I know that it sounds complex, but after today's video, you're going to be very clear about three major things of redox reaction. First of all, what the redox reaction actually are, what is oxidation and reduction reaction, and what are the oxidizing agents and reducing agents. So without wasting any time, let's make you pro. So let's first understand what redox reactions actually are. So if we just say, we put it in a definition, we can say that redox reactions are the reactions where there are movement of electrons. Now, what do I mean by movement? By movement, I mean that electrons are being accepted, they are being donated or shared. Basically, when there is a movement of electrons in a reaction, we call that reaction redox reaction. Let's see an example. Let's say we have magnesium reacting with oxygen and then producing magnesium oxide. Now, what can we see from this reaction? We have magnesium here. That magnesium is donating electrons. How many? 2 electrons. And it is producing magnesium 2 plus ion, right? So electron is moving. That means electron is moving from this side to that side. That means magnesium is donating 2 electrons and producing magnesium 2 plus ions. Now, this 2 is just number of atoms, and we have 2 magnesium atoms, 2 moles of magnesium atoms. But what it means that all the atoms are doing the same thing. So we don't need to talk about 2, 3, whatever the number is. We don't need to think about that. All the atoms are doing the same thing. So we can just say that one magnesium atom is donating 2 electrons. So there are movement of electron, right? Now let's look at the oxygen. We have O2, so oxygen molecule, but basically we have 2 oxygen atoms in there. One of the oxygen atom, what they are doing is they are taking 2 electrons, and it is becoming an anion, which is oxygen 2 minus. So in this reaction, we can see that magnesium is donating electrons, oxygen is accepting electrons. That gives us the movement of electron, right? There is donation of electrons, there are acceptance of electrons. So electrons are moving. These reactions are called redox reactions. Again, why are they called redox reactions? Because electrons are being moved. There is movement of electron in here. Let's look at another example. We have iron oxide reacting with carbon, and only iron and carbon monoxide is being produced. Now, before going to this reaction, let's know something else. When we have neutral atoms, molecules, and compounds, they do not have any charge. Let's say we have only iron, just like that in the reaction. This iron is an iron atom, which is neutral atom, so it doesn't have a charge. It has a charge 0. We can just say that it has a charge 0, right? Now, let's talk about sodium chloride. We know that it's an ionic compound, so sodium has a charge, chlorine has a charge, but when sodium charge and chlorine charge are coming together and forming a compound like sodium chloride, it's a neutral compound and it does not have a charge. So the charge of sodium chloride is also 0. Now let's talk about oxygen molecule, O2. So it's a molecule. It's a neutral molecule. It doesn't have a charge, and neutral molecules will also have a charge 0. We have to keep this thing in mind when we talk about oxidation, reduction, or redox reactions. Now let's go back to the reaction. What's happening here? The charge for iron, we have 2 iron atoms here, right? So each of the iron atom has a charge of +3. We know that. So in the result, we're getting that iron has a charge 0 now. So something had changed. What had changed? This iron cation has accepted electrons. It had 3 electrons less. Now it accepted 3 electrons. Now it has become neutral 0. That means there is movement of electrons, and we can also call this reaction a redox reaction. But other than electron, we can also explain this kind of reactions as redox reactions using the oxygen. See, we can also say there is movement of oxygen in there, right? This iron is losing oxygen. That means oxygen is moving away from it, and oxygen is going to carbon. Iron is losing oxygen, carbon is gaining oxygen. When there is oxygen present in the reaction, we can also explain that reaction using oxygen. Loss of oxygen is reduction, and when something is gaining oxygen, that's oxidation. We're going to talk about it later, a little bit later. So this is also a redox reaction because there is movement of electron, or we can say there is movement of oxygen. Now the question is, are all the reactions redox reactions? No. There are reactions where there are no movement of electrons. In that case, we cannot call those reactions redox reactions. They're basically called non-redox reactions. So we have an example. Let's see the charges. So we have a silver. We know that charge on silver is basically generally +1, right? And nitrate, another radical, it has a charge -1. Let's go to sodium chloride. We have sodium plus and chlorine minus, if we just break down then the ionic equations. Okay, now again, when you go to the product, we have sodium nitrate and silver chloride. If you break them down, you still get sodium plus and NO3 nitrate minus. And then you have silver plus and chlorine minus. So look at them now. Silver plus still stays as silver plus, nitrate stays as nitrate, sodium plus, chlorine minus, this stays as they were before. So nothing changed, right? So there is no movement of electrons in this reaction. So we cannot call it a redox reaction. Let's look at another example. We have hydrochloric acid reacting with sodium hydroxide and producing a salt and water. Now, if we break them down, again, we have H plus and chlorine minus as ions, and we have sodium plus and hydroxide minus a radical. Okay, then in the product, we're getting sodium plus and chlorine minus. And for water, we know that H plus and H minus is there. Again, you can see the charges or the oxidation state of all of them are same. Nothing changed. Sodium plus remains sodium plus, chlorine minus remains chlorine minus, H plus remains H plus, and H minus remains H minus. So basically, you can say there are no movement of electrons here, and this also cannot be called a redox reaction, and they are called the non-redox reactions. Now let's go back to our previous example where magnesium was reacting with oxygen producing magnesium oxide, and we have already seen that this is a redox reaction because there are movements of electrons in there, right? Now let's see actually what happens. Let's write the reactions again. So we know that one of the magnesium atom was donating 2 electrons and it produced a magnesium ion, magnesium 2 plus. On the other hand, we have oxygen atom which is accepting or gaining 2 electrons and producing an oxygen 2 minus cation, right? We can see that oxygen is being donated here, or you can say the magnesium is losing electron, and for oxygen it is gaining electron. When there is a redox reaction, we have 2 parts in there. The word redox actually came from 2 words. First word is reduction, and the second one is oxidation. So the red part of reduction and ox part of oxidation comes together and forms the redox reaction. So we have a reduction half reaction and oxidation half reaction. Those 2 half reactions coming together and forming one full redox reaction. Now we can see, let's come back here. We can see that electrons are being lost from magnesium. Loss of electron is called oxidation, and gain of electron is called reduction. Again, loss of electron, just like this magnesium losing 2 electrons and forming magnesium 2 plus, this is oxidation because there is loss of electron, and this is gaining electron. Oxygen is gaining electron forming oxygen 2 minus. This is reduction reaction. Gain of electron is reduction, loss of electron is oxidation. Now we can use a word, nice word to remember these things, which is oil rig, O-I-L-R-I-G, oil rig, right? If you just remember this word, you can say oxidation is losing, reduction is gaining. So if you just keep it in mind, it's easier for you to remember, but it's not needed actually. Let's get on with the theory and learn them properly. First of all, when something is losing electron, we can say that it's being oxidized and the reaction is oxidation. Something is gaining electron, it is being reduced, and the reaction is reduction reaction. Okay, at the end of this lecture, you will find a nice note on oxidation and reduction with how oxidation is, how reduction is, and examples. So don't forget to look at that result. Okay, now let's go back and see another example of oxidation half and reduction half reactions. Okay, let's look at our second example. We have hydrogen sulfide reacting with oxygen and producing sulfur and water. Let's look at the movement of electrons here, if there is any. First of all, look at the sulfur. We have a sulfur which is in a compound with hydrogen. It has a charge of -2. Look at the product. We have a sulfur and the charge is 0, right? It doesn't have any charge because it's just an atom, 2 moles of atom, right? Now, again, when we are writing about oxidation and reduction reactions, we are not going to consider the number of atoms and number of ions in front. We just want to focus on one of them, because whatever one of them are doing, everyone is doing the same thing. So we don't need to focus on the 2 moles of atom, or 2 atoms, 3 atoms, 2 molecules. We don't need to do that. We can just take one of them and show it. Okay, so sulfur 2 minus here, it has been converted to sulfur 0. That means this guy had 2 more electrons. It has lost electrons. So 2 electrons have been lost from this sulfur, and the result, we have a sulfur with a 0 charge, right? Okay, now let's look at the oxygen. Again, as I said, it's a molecule. It doesn't have a charge. The charge on oxygen is 0, and we have 2 atoms in there, 2 oxygen atoms in this molecule. We are not going to talk about this molecule or 2 atoms. We're just going to stick to one of the atom and see one atom is doing. It's enough. Okay, now this oxygen did not have a charge. That means 0 charge, right? Okay, what happened on the right side? This oxygen has developed a charge, which is 2 minus, right? It's a compound. H2 is a compound. This oxygen is part of the compound, so it has a charge there. So oxygen 2 minus. From 0, it has been converted to 2 minus. What happened there? This oxygen has gained 2 electrons. So what happened? Sulfur lost electron, oxygen gained electron. And as we have learned in the previous one, so this one is oxidation half reaction. We can just write oxidation for now. So this is oxidation reaction, oxidation half reaction. Why are you calling it half? Because half and half, they are making the whole redox reaction. That's why. Now, this oxygen is gaining 2 electrons. Gain of electron, what do you know about it? It's reduction, right? Reduction. Okay, so as we have movement of electron in there, we can say this is a redox reaction, and it has oxidation and reduction. Let's look at one last example. We have copper oxide reacting with hydrogen and producing copper and water. Now, we know we can explain this reaction in terms of electrons movement. Like copper 2 plus, it becomes 0, gaining electrons. But when we have oxygen, we don't need to do that. We don't need to get into ionic equations. We can easily say that this one, copper oxide to copper, we can say that this is reduction. Why? Copper is losing the oxygen here. Loss of oxygen is reduction, right? So we can easily say that this reaction is a reduction reaction. And on the other hand, our hydrogen is gaining oxygen. It doesn't have any oxygen now, but after the reaction, it's getting the oxygen, right? Gain of oxygen is oxidation. So when we have movement of oxygen, we don't need to get into electrons and ions. We can just mention the loss of oxygen or gain of oxygen, and we can just easily say that this is why it's reduction, or this is why it's oxidation. Sometimes in your exam, we are going to get a question like this. It will be given and say, and they will ask that explain why this reaction is oxidation or reduction reaction. You just have to say because copper oxide lost oxygen, right? That's it. Now you have seen how we can explain oxidation and reduction half in terms of electrons and also in terms of oxygen. Now let's see the total note, overall note on this one, oxidation and reduction reaction. Now let's get introduced to our hero and our villain. So we have oxidizing agent and reducing agent. Now what does the agents do? Let me ask you a question. Let's talk about travel agent. What does the travel agent do for you? Does he or she travel himself or herself? No. They just help you to travel. They don't travel, right? That's the exact same thing with our oxidizing agent and reducing agent. Let's go back to the first example. We have magnesium was reacting with oxygen and was producing magnesium oxide, right? First of all, let's write our oxidation half and reduction half reaction. We know that magnesium from 0, it lost 2 electrons and produced magnesium 2 plus. We know that it's oxidation reaction, right? Why? Because loss of electron. Now for oxygen, gained 2 electrons and produced oxygen 2 minus ion. So this is reduction. This is oxidation and this is reduction, right? Now magnesium is getting oxidized. We can understand that thing. But when magnesium is getting oxidized, it is releasing 2 electrons. So someone has to take those electrons, right? If someone does not take those electrons, magnesium has nowhere to donate the electron. Who's taking those electrons? Oxygen. So oxygen is basically helping magnesium to get oxidized. Again, magnesium is losing the electrons and oxygen is taking those lost electrons. It's gaining those electrons. So oxygen is basically helping magnesium to get oxidized. Oxygen is helping magnesium to get oxidized. So we can say that oxygen is the oxidizing agent. It is helping magnesium to get oxidized. Oxygen is not being oxidized. Oxygen is basically being reduced, but it is helping magnesium to get oxidized. So oxygen is the oxidizing agent. On the other hand, we can say that oxygen is getting reduced because it has electrons. Who gave him the electrons? Magnesium gave him the electrons. That means magnesium helped him to get reduced. So magnesium is the reducing agent. So it's just vice versa, right? When we talk about magnesium, the reaction is oxidation reaction, but magnesium himself is the reducing agent. Now, when we talk about oxygen, oxygen is gaining electron, getting reduced, but by gaining those electrons, he is helping magnesium to get oxidized. So oxygen is the oxidizing agent here. Okay, just to clarify again, one more time, that we have magnesium, it is getting oxidized by losing electrons. Who is helping magnesium to get oxidized? Oxygen. So we can say oxygen is the oxidizing agent. Oxidizing agent, right? Let's say just agent. Okay. Now, oxygen is getting reduced. We can say that oxygen is getting reduced, right? Why? Because oxygen is gaining electron. Now, gaining electron from whom? Magnesium. So who is helping him to get reduced? Magnesium. So magnesium is the reducing agent. Reducing agent. Okay, so this is it. Whoever is getting oxidized is the reducing agent, and whoever is getting reduced is the oxidizing agent. That's the thing. It will be opposite of that one. Someone getting oxidized, that means he's the reducing agent. Someone getting reduced, that means he's the oxidizing agent. So I hope this is clear. Now you'll have a small note explaining these things, what happens to the oxidizing agent and the reducing agent. Look at it and learn with the examples. I think it will be very fine for you. Before we finish, let's see another example. So we have the same example, again, iron oxide reacting with carbon and producing iron and carbon monoxide. Now we know the oxidation reaction and the reduction reaction. We know that iron oxide is getting iron, it's becoming iron by losing oxygen. That means this is reduction, right? And carbon is gaining oxygen, so this is oxidation reaction. Okay, now iron is losing oxygen and getting reduced. Who's helping him to lose the oxygen? Carbon, right? So we can say here carbon is the reducing agent because it is taking the oxygen and helping iron oxide to get reduced to form iron, right? So this is the reducing agent. On the other hand, carbon is getting oxidized because it is gaining oxygen. Who is giving him the oxygen? Iron oxide, this one. So we can say Fe2O3, this guy is supplying carbon the oxygen and carbon is getting oxidized. So this one is the oxidizing agent, helping in oxidization, not getting oxidized himself. He's getting reduced, but he's helping in oxidization. So this is oxidizing agent. So we can also explain reducing agent and oxidizing agent in terms of oxygen. So this is it for today. I hope all your doubts about oxidation and reduction is clear now. If you have any more question, you can ask me in the comment box, or if you need a special video on any topic, you can just ask in the comment box and I will try to make the video. Also, this is it for today, and see you in my next video. Bye bye.